Right, good afternoon. Welcome everybody. Thank you very much for being here this afternoon to join us for this Terragraph launch with Siklu and with Facebook. We've got some fantastic presenters today for you and some excellent content. So I'm just going to run through a little bit of housekeeping before we start. Our presenters will run through the presentation with you this afternoon with the Q&A at the end, but we do encourage you to ask the questions as we go. What you'll see is two panels. There's one for chat, which I'll be sitting on and keeping up with you guys, but if you've got specific questions for either one of our presenters, if you could use the Q&A panel, that would be fantastic, and we will address those at the end. So just a very quick introduction. We've got Shimon with us today from Siklu. Shimon has over 15 years experience in telecom and wireless, with positions in product management and product marketing. He's worked for Teledata, OCAM Networks, Airsonics, Broadlight, and Advanced Fiber Communications. And this has been addressing carriers and service provider markets. Shimon joined Siklu in February 2016, so he has a huge amount of experience and has held multiple positions in product management. Currently today, he is AVP Product Management. David is from Facebook. He is the Strategic Partnerships Manager at Facebook and responsible for relationships with OEMs. Who are technology partners on various Facebook connectivity initiatives, and this includes Terragraph. Dave has a background in wireless product management, and before joining Facebook 3 years ago, he worked on a number of OEMs in engineering and product management roles as well. This has always been with a focus on unlicensed band products, so including Bluetooth, DECT, Wi-Fi, and V-band. So fantastic presenters. Thank you very much for joining us. I hope you enjoy the presentation. Without further ado, I will hand you over. Thank you very much.
Thank you, Carla, and good afternoon, everybody. Thank you for joining. I'll start with the agenda for the presentation, where a little bit of introduction about Siklu and what we do in general. Then Dave will present the Facebook involvement with Terragraph. We'll talk then more in details about the MultiHaul TG solution, how to design a network, and then we'll close with a Q&A. So for those who do not know Siklu, we are in business for over 10 years now, present in over 45 countries, more than 100,000 units deployed, and we offer solutions all over the millimeter wave spectrum, 60, 70, 80. We are objective leaders in that space in the US and in the UK, as you can see here from the number of units, also from the number of links recorded in the Ofcom and in the FCC databases for equipment. Why are we focusing so much on the millimeter wave? That's very obvious when you look at the fact that everybody, certainly in 2021, after 1 year plus with the COVID saga, is trying to deploy more connectivity at higher speeds everywhere possible. The traditional options are, generally speaking, fiber or 5G NR, and they have advantages, they have disadvantages. We believe after many years in this market that fixed 5G based on millimeter wave is the one solution that solves the problem, as well as avoids any of the challenges associated with fiber deployments or 5G NR. The range of solutions that we offer at Siklu, we start on the left here with full duplex 10 gigabit links, which can go in distances anywhere from almost 5 to over 10 kilometers with extended MM, different antenna sizes and different combinations of equipment to achieve all this. Then we have, I would say, lower capacity, shorter range, point-to-point radios, the EH600, 700 family. And then we start moving over to the right with the first point-to-multipoint family that we launched over 3.5 years ago now, a little later in the UK when the point-to-multipoint was allowed, which is relatively short range, 300 to 400 meters, a total of 1.8 capacity. And end of last year, we launched our point-to-multipoint mesh solution, which is Terragraph certified with the help of Facebook, which allows for greater capacities, denser networks, and most important, the ability to self-organize within an SDN environment. So what are the applications that we target at Siklu in general? They are arranged in these 4 main verticals, starting from smart city and the different sub-applications within this vertical, ranging all the way to internet access for community connectivity, residential, as well as rural connectivity. And all of the different pieces of equipment that we deliver at Siklu, whether it's real equipment or pure software, combine one way or another to address all of these different applications. Basically, when we try to look at it in the real, that's how, for example, we combine them for gigabit internet access. So we have our wherever the fiber ends, that's where Siklu starts to deliver solutions. We can do gigabit internet access for mid and high rise with our point-to-point solutions, and we can extend the reach of the fiber all the way into a neighborhood and then go low rise with our MultiHaul TG solution nowadays. All this is going to be managed with our EMS solution, and we basically help everybody understanding how all these different pieces of the network can combine best together. How does the real solution look like with the help of our wireless network design engine, which is available software as a service on the cloud for everybody on this call, I hope, by now. And then if we go, for example, into a different application like mobile or small cell backhaul, you can see that it is a very similar arrangement. We start with the wireless network design engine, EMS, to monitor the solution, and then a combination of point-to-point and point-to-multipoint radios to go all the way to the small cells. And if we look at a smart city, again, it's a very similar arrangement of different of our radios to achieve that solution. And I know I would not like everybody to think that it's all about bits and bytes and distances. At the end of the day, what we do at Siklu really matters to end users. We definitely realize all this, again, a year into the COVID situation, where everybody understands that internet access is not something about entertainment or maybe exchanging a few emails here and there. We all understand now that it addresses, it impacts all of what we do every day. Everybody in the family, if we think about working from home, like I'm doing today, relaying this presentation from home, or studying, whether it's K to 12 or even college and universities. Most of the courses are still available remote only, depending on where you are today, whether which country and how advanced they are with resolving this situation. Working, applying for work, banking, anything that we do basically happens nowadays over the internet. And we're looking, for example, beginning of the year, together with Digital C in Cleveland, at their situation where they realize that they have 50,000 homes, so even more persons affected, with no decent internet access. We were working with Digital C trying to help them in 2019 to connect library and schools, and they realized that that was a good start, but that was not going to address again these 50,000 homes. So we changed the plan. They changed the plan, and they asked us to help and connect these unconnected. We managed to close almost 1,000 homes during the course of last year as a blueprint for how to do it, not just the equipment, but also the staff, the method and procedures, all what is needed to really to come up with a cookie cutter solution to replicate these deployments at scale. And we continue to work with Digital C in 2021 to do more of this. But bottom line, that really helped us to understand that it's not just about going another 100 meter or another gigabit more of capacity. It's what we do affects families and kids and adults on their daily lives nowadays. With that, I'm going to turn over to Dave to share the Facebook involvement in Terragraph. Dave, please go ahead.
Thank you, Shimon, and thank you, Carla and the team at Purdicom for hosting this webinar and having me join. It's really a privilege to be here today. So indeed, I'd like to take a brief detour from Shimon's launch materials on Siklu's Terragraph product and just give a quick background on Facebook's involvement and the origination, the origins of the Terragraph technology at Facebook. Shimon, if you could advance to the next slide, please. So I work in a division of Facebook called Facebook Connectivity. And really, we have a fairly simple mission, which is to bring more people online to a faster internet. So within this group at Facebook, we have a number of projects and initiatives underway which serve this mission. And basically, we're all measured against how many people we're bringing onto the internet and how we're increasing internet speeds. The idea is that this really rolls up into our overall corporate mission as Facebook. And of course, it's good for our business as Facebook to have people more easily and at greater scale have good connectivity. Now, there are, of course, a number of connectivity challenges and barriers that we evaluate. If you could advance to the next slide, please, Shimon. And each of the different programs under the connectivity umbrella at Facebook look to solve these particular challenges. In the case of Terragraph, which is one such program under connectivity, the let's say the problem statement or the challenge it sought to address is that last mile connections for especially gigabit per second class connectivity were very expensive and time consuming to deploy, primarily because the de facto standard for deploying these connections was via fiber. And as you, I'm sure, know, trenching for fiber and burying fiber is an expensive and time consuming ordeal. Therefore, for this problem statement, Facebook got to looking at, what are some wireless alternatives or solutions that could mitigate this challenge. Next slide, please, Shimon. Very quickly, the V band, the 60 gigahertz band, emerged as an attractive piece of wireless spectrum to work with to solve this challenge. It's unlicensed and freely available in many parts of the world, not all, but we're also working on that. And there's just so much of it. There are multiple gigabits in some cases, I think up to, it's over 11, 12 gigabits, gigahertz of spectrum available for 60 gigahertz use. So at those bandwidths, it's fairly easy to see fiber-like capacities being available. Next slide, please, Shimon. So just conceiving of how the 60 gigabit spectrum could be used to basically deliver connectivity in a fiber-like manner, we began conceiving these, let's say, architectures and schemas which address urban, peri-urban type settings where you could have multiple nodes deployed throughout an area, like depicted on the slide, connecting to one another with 60 gigahertz, basically pencil beams. You're going to need these high gain phased arrays to close links between nodes, and basically deploy these in a mesh-like fashion. And with this type of an architecture, with a limited number of points of presence, connectivity points of presence, which for Terragraph typically are fiber pops, the broadband capacity can effectively be distributed very broadly over an area. The mesh capability of the technology allows some of the challenges of 60 gigahertz deployment to be mitigated. For example, line of sight challenges, some of the obstruction type challenges with it, link reliability. If you deploy a mesh and you build redundancy in that mesh, you can basically not only, of course, have the flexibility of the mesh to move around line of sight obstructions, but should any of those links be impacted, the mesh should be resilient enough to recover. So this was the high level concept, 60 gigahertz allowing high capacity links between these mesh nodes. And so we got to working on this, and this all started, I think that it was about 6 years ago at Facebook, give or take a few months, that this all began in earnest as research. So next slide, please, Shimon. We got to work basically prototyping at that time. So you can see here some photographs of some of the early link testing that we performed. These are pictures from our Menlo Park campus in California, where we were, I believe, shooting some of these links, testing out some phased array antennas. And we not just the links, but of course, these other aspects of the Terragraph technology, the mesh, the control and management systems, all of that sort of deep R&D began at Facebook at that stage. Next slide, please, Shimon. Sorry for the pause, folks. There's a bit of a delay on me seeing the slides. So, of course, all of this R&D work and this development, it was intended from Facebook's point of view to enable an ecosystem and to enable this technology to come to market. Facebook is not a service provider or an OEM, and sometimes that's a simple but important point to make when we're present in these discussions about Terragraph, because these are the typical entities you see involved in discussing a new technology in an ecosystem. So we played a slightly different role, sort of, let's say, doing the R&D, defining the standard, if I can call it that, and contributing it into the ecosystem. So the way we externalized the Terragraph technology once it was defined, or as it was being defined, was in a number of ways. One aspect, was that we actually contributed many of the definitions and the designs into the IEEE 802.11ay standard. So if you go and look in there under the distribution network section of the AY standard, you'll see a number of contributions from Facebook, which effectively encapsulate the Terragraph-like functionality at the link level. This is at the up to sort of MAC and PHY access layer. The other way that we externalize this technology is basically forming up a license scheme. So it's licensed technology, and Facebook licenses the Terragraph software stack to our OEM partners, royalty-free. We don't make any money from this. Again, the objective is to bring more people online to a faster internet. So we really measure that as far as Terragraph success more than anything else. Next slide, please, Shimon. So beyond just defining the standard and doing that deep R&D ourselves, we also realized that there was a chicken and egg problem to solve in terms of getting an ecosystem to adopt the technology. OEMs aren't going to build a technology unless there's a demand for it. And of course, service providers will struggle to, say, articulate a demand for the technology if they've never seen it working. So Facebook got to work actually building reference designs so that we could break this chicken and egg problem and actually demonstrate to the industry that this technology is effective and show the types of things and problems it can solve. So you can see on the screen here some early prototypes, concepts of full, what we call reference designs that Facebook built. These have gone through a number of iterations, and they were certainly very important and let's say effective in terms of breaking this chicken and egg problem and allowing us to go and launch trials. I must comment that our OEM partners in commercializing the technology have done a spectacularly better job at the aesthetics of things, and just point out that we were trying to at least demonstrate the technology here. So forgive us on the aesthetics of some of these designs. It was very exciting to see the technology work nonetheless. Next slide, please, Shimon. So taking these reference designs into scale deployments was very important. Our first one was actually in San Jose, in our own backyard in the San Francisco Bay Area in California. We deployed a several hundred radio mesh in downtown San Jose, and you can actually see the map layout of that mesh depicted on the left of the screen and some screenshots of the types of mounting locations. These nodes were hung on both street lights and a few building rooftop assets throughout the city. And this proved extremely valuable in terms of just proving out the scalability of the technology in terms of how large a deployment can run. And it was also a great partnership with San Jose in that it allowed us to have effectively a sandbox or a test bed to continue developing, refining, and improving the performance of the Terragraph technology in this real world environment. Next slide, please, Shimon. The next step after doing these sort of close to home trials with Terragraph was to put it, let's say, even further into the real world, into more demanding scenarios. And this is where Facebook partnered with a number of service providers worldwide. There are just 3 depicted on the slide. We've partnered with many more, but just a few early ones to note. Magyar Telekom, a subsidiary of, or let's see, an OpCo of DT. They're based in Hungary. We deployed a fixed wireless access network there with the reference products. Big deployment in Georgetown, Malaysia, that's still in operation today, and in Aeronet, Puerto Rico as well. These early deployments with service providers and real customers using the connectivity afforded by Terragraph were also fundamental to demonstrating the commercial possibilities with Terragraph and really showing the service provider community that the technology works. These were all, again, started with Facebook reference products. So where we are today with our OEM partners, having licensed the technology and worked to support OEM partners to bring the technology to market, we're at a very exciting phase where all of our partners, and Siklu here especially, are launching their commercial solutions. So Facebook doesn't intend to continue deploying these reference designs in trials to demonstrate it. We believe that job has largely been done, and the exciting phase that we're at now is to see our partners launching products and really seeing this ecosystem take off. Next slide, please, Shimon. So if we take a look at where this ecosystem stands today, and again, I should emphasize that from Facebook's standpoint, it's all about us jumpstarting this ecosystem, supporting it, and making sure it's healthy and underway. So we actually licensed the technology and have worked with 6 OEMs. Of course, Siklu is one of them. You may have heard of some other launches of other Terragraph OEMs. There's 6 in total in the fold. We've been getting involved with some of the supply chain components, in particular the radio chipset provider, which is Qualcomm, and antenna module vendors, and basically helping these supply chain components, or at least helping ensure there's a healthy ecosystem of supply chain components necessary for Terragraph product development. I mentioned that there were a number of Facebook-led trials. That was a phase of the program that was important to break the chicken and egg problem. Now our OEM partners are engaged with a massively larger number of service providers, which is fantastic to see. We're also seeing systems integrators and the channel partners of our OEM partners ramping up on Terragraph expertise and beginning to get their hands on demo kits and basically testing and learning to deploy the technology. We're also, as Facebook, very active in tool development to help automate and facilitate the deployment of Terragraph. So we're working with our partners, for example, with a automatic network planning tool that makes the planning of Terragraph, which is a new sort of exercise for many, given that it involves line of sight technology deployed in a mesh. It's definitely something that with automation can be expedited and made much more convenient. So it's another key pillar of our efforts in supporting the ecosystem. Next slide, please, Shimon. So if we look at the road ahead for Facebook's involvement in the ecosystem, at present, right, we're very excited to be supporting our OEM partners such as Siklu here today, launching products and supporting them in their go-to-market in a number of segments that really resonate with our mission, right, which is to connect people to the internet. So supporting our partners, and really what we aim to do going forward is continue to be, maybe I should call it a custodian of the technology. We obviously care very much to see our vision through and see the technology be successful at connecting people. So Facebook intends to remain involved. We have continuing engineering activities in terms of working with the silicon suppliers and the reference architectures, etc., to bring new features into the technology. We continue to engage with regulators worldwide to advocate for the de-licensing of the 60 gigahertz band. And of course, we continue to engage with service providers worldwide to ensure that there's a good value prop understood for this technology, that they can see what problems in their networks it can solve. So that's the type of activity we aim to continue and really, again, be a custodian and to ensure that the technology, persists and can successfully connect people. So with that, I'll hand it back over to Shimon. Thank you, Shimon.
Thank you, Dave. So let's talk a little more now about the MultiHaul Terragraph product line. You will understand very quickly that what are the advantages of this class of products. First of all, we've done a lot of work on the integration. We've integrated 4 sectors of Terragraph inside a single box, which means that it's a single installation, it's a single power, it's a single management interface for all this. And there is also a built-in switch, which eliminates the need for any additional box at the installation of this node. Again, all integrated within the same management interface. And we'll see a little bit later what it's going to do in the product. But we have also made some additional decisions in the way we want this solution to go operational, so that it will integrate very quickly in a lot of practices for the billing and the operational support systems, so that it won't take a lot of time after the organization is satisfied with the performance of the product to connect it into the operation systems of the organization and start offering service right away, not have to wait a year or two like it might take if with other choices. Siklu is in the market of millimeter wave solutions for more than 10 years now, over 5 years in the 60 gigahertz spectrum with products in the field. So we have learned about a lot of the challenges and what works and what does not. And we understand that we need to offer a range of solutions to address different distances, short and medium and long, with different types of solutions, starting with beamforming and reflectors, all this based on the designs that we can make at Siklu, which are going to be unique to the products that we develop here. You are going to see that our products are very easy to operate. They work out of the box with no additional software in the cloud. Nothing to install, nothing to configure. It's just there. We also make sure that it's very easy for the staff to understand what this equipment does, because it's just a switch. It can be a simple or an advanced switch, but it is a switch like any other equipment that one normally operates in the access network. Whether you do DSL or fiber or GPON or maybe another wireless technology today, what the staff and the organization dealing with the last mile normally does is use switches, and we make sure that our equipment is yet another switch, so that it doesn't take any kind of additional training to know how to configure and operate the network. From the point of view of IP connectivity, as far as management stands, that's the only place it matters for us, because we handle the traffic as just layer 2. So for management, we are going to offer a choice of IPv4 or IPv6. And then we have made some additional decisions, again, within the scope of staying a layer 2 entity only, which means that it will impact the kind of latency that our equipment is going to offer. It will result in a higher packet per second performance, within the same silicon, because there is just a little less work to do when you work at layer 2 compared to layer 3. And because we are at layer 2, we offer a complete VLAN package for the organization to choose from, whether one wants to operate C VLANs, S VLANs, or Q&Q with double tags, depending on the kind of service configuration the organization likes to deploy. All that is available, and you can continue basically to operate your last mile network with the MultiHaul TG any way you operate it today. You do basically more of the same. How does it look like as far as the solution? Obviously, you have your fiber coming into the service area, and again, if the fiber is not available all the way, we have a range of point-to-point high-capacity links to choose from. And obviously, we'll have a first node starting the network. We'll explain the interfaces in a few slides. And from there, we extend a mesh network out of these different nodes, which is going to go across the service area with different levels of redundancy. What is nice is that this same node, which is deployed as part of the infrastructure, is going to do both the self backhaul, so going from the fiber to one node to another node to yet another node, doing the self backhauling, as well as offer access to the different terminal units that we are going to offer as part of the solution. So it's very simple, one box to extend the network, and then just a matter of configuration to make it work as a combination of backhaul and access at the same time. Because we have very smart antennas as part of the solution, both in the nodes as well as in the terminal units, it means that we can offer also different types of redundancy. You can choose to have redundancy as part of the backhaul. As you can see here, every node can be connected to one to more other nodes to maintain any kind of level of redundancy that you would like to achieve in your network. But because we have also scanning antennas inside these terminal units, assuming that you connect your terminal units, or you orientate your terminal units where it can have field of view to more than one node. So if the serving node would fail for whatever reason, then the network will pick up this terminal unit from another node in the network, so that you have basically an additional option for redundancy if you want to. What is also important is that these terminal units are mostly going to do the service to the end customers, but because we have similar facilities in terms of port types or bridging configuration in the nodes too can be used to offer services. You can install them on top of homes, on top of critical customers with redundancy options if you want to. So the way you organize the network is very flexible. You can go into Windy and drive the network architecture any which way you go. I'm sure many of the audience has been already working with our wireless network design engine for a traditional MultiHaul series for the past few years. And you can see that it has been upgraded a few months ago now to offer also an option to design with MultiHaul TG. So same user experience, Same quick results with bill of material, frequency planning, best optimization for placement of the nodes. All that is available. Again, same user experience. And all this infrastructure is ready to be operated with the cloud. So in the cloud, we will offer a combination, in your cloud, we will offer a combination of NMS and runner, depending on the level of automation that you would like to deploy. Today, we have our EMS, which some of you may have seen already, has been upgraded also to manage the MultiHaul TG solutions, and will continue to do some additional enhancements during the year, as well as adding runner. So that means that you can operate today the MultiHaul TG solutions. As I said, nothing needed in your cloud to make this all work. It's very simple to operate from the user interface. But if you want a little more automation or a lot more automation, then we will build all this gradually within the NMS and the runner as we go, and as we understand what is going to be important for the audience here. Dave has done a great job to explain what Terragraph is, and we at Siklu have been working with service providers and other organizations for a number of years, deploying small and larger networks. We looked at Terragraph, we saw a lot of good things. We saw a few things that we think that service providers may want to see a little bit different. And I'm just going to outline here a few of the differences. As I said earlier already, we have decided to operate all the network as a pure layer 2 solution. So there is no routing protocol, no routing skills necessary. Just like you build your last mile network today with layer 2 switching, whether you do DSL, fiber, GPON, you are going to see the same out of the Siklu solution. We have made sure to integrate all of what would be needed in the backbone inside one box, because we understand that time is money, and if you have to install or operate 1, 2, 3, 4, 5 maybe different boxes, that's just more pain than is necessary. And it's taken a lot of expertise to do it, but we're happy to see that it's working quite well. And I know that equipment is on the way for many of the people in the audience here. We talked already about the out-of-box experience. At Siklu, we have offered solutions for many years now, which work out of the box with nothing additional needed. We replicate a lot of this in our MultiHaul TG solution. And let's move to the next slide and maybe talk about the N366, which is our backbone node in the MultiHaul TG solution. So it is Terragraph compliant. We have 4 sectors in the box. You can see 1, 2, and then 2 more sectors around here to cover the full 360 degrees out of one single product. Each of these sectors can connect to 15 other links. If there are just terminal units, there will be 15 of them. If you want to build self-backhaul links out of these sectors, it's going to be 1 or 2 of these self-backhaul links per sector up to time 4. And obviously, if some of the links are backhaul, they cannot be for terminal units. So the rule is very simple: 15 times 4, 2 times 4 again, and any combination in between is also possible. Each of these sectors is built on the latest chipset from Qualcomm, 802.11ay capable. Will be upgraded to AY within the year as soon as the software from Qualcomm is available to us. As you may know, the Terragraph solution runs with GPS in every node. We have one here at the top of the node built inside the box. And the connectivity is built with a TDMA protocol. Again, thanks very much to Facebook for having worked on all this and making sure that it works very well. Because we keep this as a layer 2 solution, we achieve quite interesting latency, which is in the range of 0.1 millisecond per hop. And because it is TDD, we can guarantee that latency across the network. if one thinks about what it is, why is that important really to your organization and more so to your customers, it means that in terms of internet access experience, whether you have 1 or 10 hops, you are going to have a round trip delay, which is going to be measured in 1 or 2 milliseconds, which is not going to affect the internet experience by any means. It was important for us to achieve this kind of performance. And we tried also with the routing protocols. We saw that it was going to be a much higher latency, which would affect then the internet experience, in the range of 20 to 40 milliseconds, which we think is really not acceptable. So that was another reason for us to stay away from routing protocols. There is a layer 2 switch built inside this node, which aggregates the 4 sectors and really is behind a lot of the point to multipoint backhauling that goes into the network. There are 3 ports under the N366 here, and basically the switch has complete access to all of the 4 sectors, the 60 links which can be built out of the 4 sectors, and the 3 ports to allow you to configure any kind of switching arrangements that you would like. You can see that the N366 is really not very big. It's less than 7 inches in diameter, less than 9.5 inches tall, so really small. There are 3 ports under the N366. The first one is a 10 gigabit together with the PoE into the box. The 10 gigabit can negotiate all the way down to 100 meg. So any kind of copper port that you might have either on your data center or at one of your customers can be connected to this N366. The second port is 1 gigabit PoE out for maybe a Wi-Fi backhaul or a camera or anything like, with PoE out on that port as well. And the third port is an SFP, so that you can connect any kind of fiber at 10 gigabit or 1 gigabit, multi-mode or single mode. We have a choice of SFPs to allow any of these kind of connections. We get a lot of questions as why did we think about building a 360 degrees product inside one box. And again, thinking about the kind of deployments, if you go along streets or along or across residential deployments, anywhere you have a pole, you can basically cover with 360 degrees and a single box. If you have access to the top of the pole, you can see the result here, no obstruction and full 360 degrees. You can also mount on top of the pole. We have those who have seen the N366 from close will see that there are different options to mount it. It's very easy to install. There is a bracket in the box together with the 2 bands. You just mount the bracket to the pole with the 2 bands, and then you slide the N366 down into the bracket. It won't fall, don't worry. And then you just have 1, 2, 3, 4 screws to secure the N366 to the bracket so that it will stay there, even in winds of in excess of 200 kilometers. What happens if you do not have access to the top of the pole? Like we can see here, then there will be some obstructions. Mechanically, there is no problem. Your pole can be from 1.5 inch all the way to 12 inches. The bracket here will accommodate any of these diameters, and there is no mechanical interference. We have done a lot of calculations, simulations, and testing to see what will happen with different types of poles, and obviously the metallic ones are the most challenging. If you have a 4 inches pole, you just lose 20 degrees of coverage across the 4 sectors. So yes, you have a little less coverage, nothing really significant, even with a 4 inches diameter pole, and you still have ability to set up 60 links. So that's quite a lot of connectivity that can be done, even if there is one pole there. We can share with you information, what if you have 8, 12 inches pole, as well, or lower size, and tell you what's going to be the impact on your deployment. Windy is aware that the blockage is possible and will make sure that the orientation of the N366 relative to the pole is going to be calculated so that the links which should be served from that location are not blocked by the port. So we have really a complete solution from that point of view. Let's talk about the N366, about the T265, which comes in two flavors. We have a single port solution or a 3-port solution. It's 1 and 2.5 gigabit, so that you have some capacity for some future upgrades. For example, when we activate channel bonding in this product, or you have a 3-port solution with even a fiber port, so that if your customer doesn't want to trust a surge protector for good isolation between the outside and the inside, if their equipment is quite valuable, then you can connect your end customer with a fiber drop, again 10 gigabit or 1 gigabit, whatever is going to work for them. The second port here is a PoE out, again 1 gigabit, this time with 55 watt, so that you can even connect a good PTZ camera out of this T265. And we have more flavors of those coming down the line. Simple operation, as I said, you don't need anything in the network. You just connect to your first node, which is connected to the fiber, go into the user interface, tell it to activate these 3 links, which just by the name of these units, which can be by default the serial number of the unit, or anything that you want to use as a name, maybe the phone number of the end user, maybe the street address, and maybe just a nickname for that location, just a string of letters and numbers that you can use, and which can also be your secret ID, so that it's very easy to interoperate with your operational support systems. You don't need a mapping or a cheat sheet between what is the location and what is the MAC address or anything alike. So this unit will be responsible for setting and maintaining the 3 links, and this one, another one, and basically you can build your mesh very easily. No additional software needed anywhere. I'd like to talk also very quickly about deployment options. We have a lot of experience doing and helping service providers and other organizations to decide how to build a good deployment scenario. We can help you very quickly to qualify a service area, whether it's a good or less than optimal for millimeter wave, MultiHaul TG type solutions. And then we can help you design a test area, check what would be the marketing approach, validate the marketing approach, pre-sale, and then if all this works, continue to densify your network. And we have a number of tools and methodologies being built behind these tools to basically understand what's going to work best and validate it for your network. So with that, I think it's time to turn over to the Q&A. Is there anything in the pipeline, Carla?
Yes, there is many questions. So yeah, thank you very much, Shimon, and thank you, David. Yes, we can run through these. So we've got the first one came in here that says, how does one get more information on the automated network planning software? And I believe that was in relation to one of Dave's slides.
Yes, I'll take that one, Carla. Thanks for the question. So with our automated network planning software, Facebook actually has a direct engagement with our OEM partners on that. So my guidance there would be, please work with your vendor, please work with Siklu on their automated network planning solution. Each of the vendors in the Terragraph ecosystem has adopted this or looked at it in different ways depending on their product. So that's the best approach I would recommend. Please talk to the vendors and go through them to get guidance on network planning software.
Thank you very much.
What I'd like to add here is, again, if anybody is aware of the wireless network design engine from Siklu, which you can connect to at winde.siklu.com, you can self-register there, and we'll make sure that you can use the tool. If you are not aware of it, we'll train you to using the tool, and you'll be able to design your own networks, understand how the MultiHaul TG solution can work for you very easily.
And what I can do as well is within the follow-up to the webinar, I'll include some information on that email as well.
Great.
Yeah, no problem. So second question we've got here, and this I believe was, I think this is for you, Shimon, and this was in relation to the scalable networks slide. And Gino asks, can you share the config or management GUI?
So you can connect to each of the nodes or the terminal units. Some of you may have already experience with our existing MultiHaul Classic. We have a very similar experience. You can connect to each of those and build your network from there. Configurations are saved. You can download, you can upload configuration, etc. You can share scripts from one unit to another one as well if you want to replicate it quickly. And you'll be able to do more of the same from the EMS and MS tools or from the runner when they are gradually being richer in features.
Fantastic. Another question here says, so Siklu MultiHaul is layer 2. How do you manage the failover in network mesh? So is this STP, RSTP, or do I need some other equipment such as routers to manage different routes in the mesh?
That's a good question. Thank you for asking. Some of you may have seen already some of the larger networks which we built with redundancy on our EtherRoll family, where we use a combination of ERP, ERPS, and VLANs. So we are porting all of this capability, which is a layer 2 only, just like it is built today on our EtherRoll family. We are moving it to the MultiHaul TG family. Slightly different choice of protocols, but very similar layer 2 capabilities, where the MultiHaul TG nodes will monitor connectivity all the way to the fiber point of presence, and will switch over from one route to another one automatically.
Excellent. Another one for you, Shimon, I think. So you said that the N360 has 4 sectors supporting up to 15 users each, stroke 2 backhaul links. I didn't catch how that stacks up. So is it 4 sectors plus 2 backhauls, or 4 sectors, 0 backhauls, or 2 sectors, 2 backhauls?
So the math is very simple. It's we have 4 sectors. Each sector is capable of a maximum of 15 links to other terminal units, or a combination of 13 links to terminal units and 2 links to for self backhaul. And then all this can be multiplied by 4 again, because we have 4 sectors and they all work independently.
Fantastic. Another one here on the Q&A, which says, how much is the vertical degree coverage? Again, another one for you, Shimon, I believe.
Yes, different Terragraph solutions will work differently depending on the kind of antenna which they have adopted. We have designed our own antennas, looking at the kind of deployments that customers try to achieve, with different in height, for maybe the node and the served unit. Whether you want to go across the street or maybe deeper into the neighborhood. We have built today vertical scanning capabilities around plus minus 25 degrees, which means that even if you have up to 5 floors difference between a node and a terminal unit, for example, and they are just across the street, so very steep angle between the two, they will still connect at full capacity. And obviously, if the terminal unit is far away from the node, then the angle becomes less and less steep, so it's easier to be in the main lobe of the antenna. So, but the magic number is plus minus 25 degrees.
Fantastic. We've got 2 questions here, which I'm going to kind of address together, which were around long-range subscriber options. So somebody's asking, are they available? And somebody else is asking, when are they going to be available?
Well, I guess it's a 2-for-1. Thank you.
I hope it goes together. Okay.
Yeah. So we are building long-range solutions. We'll talk more about these products in just very few weeks now. But for the sake of let's hold our breath then. The intention is to go 500, 700, maybe a whole kilometer. We are in the final testing of how far we can go with different sizes of antennas, because we understand that it's also important to offer a choice in terms of maybe one wants to go a little far away, but they still have to be a little discreet. So we can't afford a very big antenna. So we'll see different sizes of antennas to be able to go either farther or a lot farther, depending on the size of antenna that one can afford.
Amazing, that's fantastic. Definitely another one for you, Shimon, popular this afternoon. There's one here that says that a lot of manufacturers do have the Terragraph offering. So why Siklu?
That's a good question. Let me think a moment about this one. I think why Siklu? Because what you see today in the MultiHaul TG and what you will see going forward in the MultiHaul TG solution is the result of 10 years of millimeter wave experience, a 5th generation of 60 gigahertz products, a 3rd generation in the point to multi-point area already. So that's quite a lot of experience where we have learned what service providers or other type of organizations need in their products for their business case to work, for their operations to go smooth, for the services to be reliable, for the deployment to be very easy to engineer, and then for all this to integrate into the systems of the organization for one. An example of this is that we have kept the whole MultiHaul TG solution as pure layer 2. We have been doing redundant meshes already, utilizing our Iterol and strict layer 2 protocols. So we know it can be done, we know it scales, and we know it's very easy to deploy. And most importantly, it's very quick to switch over with autonomous decisions, no need for a controller. So we are taking this experience with us and bringing it to the MultiHaul TG family. As another example of what we have learned is that it must be 360 degrees. We have done a few deployments with the existing MultiHaul Classic, where it's 90 degrees, and then we needed a few boxes at any important location to cover more than 90 degrees. It's possible, but it does not scale, and we wanted to make that no issue for the audience here and for anybody that is going to be interested going forward. Another thing that we have learned is that there is no one solution. It's really important to have a range of options. When it comes to the terminal unit, you need large ones with multiple ports. You need different speeds. You need copper and fiber options. You need PoE out. You need distances. So all this is coming into the product line slowly but surely. We realize that things like IPv4 is still what a lot of the service providers do in their network. Even though everybody claims, I guess, for more than 10 years now that IPv4 is exhausted and we absolutely need to move to IPv6. Guess what? Most everybody still works with IPv4, and we wanted to make that still a part of our product. We understand that some organizations will absolutely want the high degree of automation that a controller can offer, but not everybody will be comfortable initially with this kind of additional challenge in their network, dependency maybe on some IT staff, which doesn't run at the same speed as the network organization. So we make our solution work with or without a controller. And maybe last but not least, we make the planning tool available to everybody so that one can start tomorrow if they want to understand how the MultiHaul TG solution can work in their network. If you can't make it on your own, we help you operate the Windy solution. So as I said, you can understand the benefits and the potential of the MultiHaul TG in your applications.
Yeah, fantastic. And also supported obviously by Purdicom and your account manager also. So do get in touch.
Fantastic support that we get from you guys in the UK, definitely.
Fantastic. So just back to a couple of technical questions here. So does the unit support 10G copper connection with PoE in?
Yes, the first port, the one which is closest to the grounding point, very easy to remember, is a 10 gigabit copper port, RJ45. Recommended to use Cat6 or better if you want to achieve 10 gigabit over any kind of distance. And that is also the PoE in to the unit. We can do PoE active, full 802.3 BT compliance, or we can do it passive. We have a choice of power solutions available that Purdicom is ready to explain how they work. And we can also, if you just happen to have a 48 volt DC battery in your location, we can convert the 48 volt DC, just a small connector that is going to take a pair for the 48 volt DC, convert it into a 4-pair RJ45 connection, so that we can use even simple 48 volt DC to power the N366 or the T265.
Fantastic. We've still got quite a few questions here, so I'm hoping everybody's okay for time. There was just one here, which I think is probably quite a quick one. Do we need special tools to manage the hardware?
Not really. In terms of, you can just come with your PC and a browser or anything that can do SSH. For the CLI, plenty of software available, which we have been recommending to our users to operate any of our Etherroll or MultiHaul solution. So anything that can do SSH, anything that can do HTTP, that's all what you need.
Brilliant. And another question here. Are we able to influence the way traffic flows through the mesh?
Actually, you can, because we have full VLAN capabilities. So you can build C VLANs or S VLAN or a combination of C and S, depending on the kind of service that you offer to your customers, and basically use these to steer the traffic across the mesh in a way that you would like.
Superb. I actually had a question here as well, which was submitted earlier, which was, what is the vertical beam width of the Terragraph base unit, and the same for the client radio?
So both the N366 and the T265, the node and the client, or the terminal unit, both have a plus minus 25 degrees scanning capability. So it's not really a beam width, it's really the beam will be adjusted anywhere in that range. The beam width itself is 10 degrees, so it's quite narrow, as is common in the 60 gigahertz. But we will really adjust it up and down, right and left, so plus minus 45 degrees horizontally, plus minus 25 degrees vertically. We're not blasting all across that range. I said, we make very narrow beams, as Dave explained earlier. That's a must to achieve any kind of distance and capacity in the 60 gigahertz range. So plus minus 25.
Superb. And the last one, which I'll answer, was just one around stock availability. Just like to make everybody aware that Purdicom is actually placing an order at the moment, so today. So do speak with us, speak to your account manager directly. But yes, everything is now available, which is fantastic news. So I think we are probably ready to wrap up, unless there's any other questions. And I don't think so. I think we've got through everything that was submitted, so that's fantastic. I'd just like to thank everybody again for attending today, and I just want to make you aware as well, we do have the recording, so I will follow up with some information, as I mentioned before, on Windy, and also the recording. So yes, thank you very much, and thank you again to our fantastic presenters today as well. We're very grateful.
Thank you, Carla, and thank you for everybody joining today. It was a pleasure to explain about how we can help.
Likewise, thank you, Carla. Thank you, Shimon, and everyone for listening.
Thank you. Bye-bye.